context behind that, or I just walked in? No context.
No context. Yeah. Yeah. Other than that, you can tell I have this odd obsession with like tacos and hot dogs and sandwiches and such. But no, there is a reason for that, which we'll talk about. Yeah, yeah. But sticking with my theme, right? We are on the topic of functions, right? And we said functions, they take stuff as input, they do stuff, and they have outputs. So we have a taco making machine, which makes a taco. We've looked at this several times. This is the function definition. Hopefully this is getting familiar. You really need to know this stuff, and here's why. Anybody who has taken programming classes before, we will eventually get to interfaces and objects and classes, right? But that's actually what's taught in the follow-on course from this. So the fact that we get to it is almost like a bonus. So you'll be a little bit ahead of the curve when you go into that class. But we will be working on our projects in about a week and a half. Those are all going to be functional programs. So you need to know how to write functions. So again, just to recap, this is not on the exam on Monday. This is the last day I'm going to talk about these. On Friday, we're going to do exam prep. On Monday, we're going to do the actual exam. Wednesday, we will do one more module on functions, and then we'll carry on from there. So you'll be fully equipped to do the projects. All right, in lecture Monday, we talked about stubbing out our functions. And Zybooks had 3 pretty reasonable methods to stub out your functions. One was when you're writing your function and you're just getting started using print fixedly and potentially returning -1. This concept of pass, the keyword pass inside your function, which means the function's not going to do anything, but it's not going to throw an error. The opposite of pass would be raise. So there was the keyword raise with the error or the exception, not implemented error. And we walked through what those different things would do when you ran your program. None of them are right. None of them are wrong. It depends on the situation. It depends on how you want to develop your code. Okay, so function arguments. We have to do a step back. Mutability. What does that term mean, mutability? It means, something can change. After we create the object, we can change it. Before we get to it in Python, what are some real-world examples of something that's mutable and something that's immutable? This chalkboard, is this mutable or immutable? Can I change what's on it? I'd say that's mutable. Had we had a textbook, is a textbook mutable? No. I mean, once you write it, unless it's like a digital textbook, once you have a textbook, once you write it, that's it. It's that way forever. What were some of the immutable and mutable data types that we talked about in Python? What were the immutable ones? What are the ones that can't change? String. What else? Tuple. Name tuples. Integer, float, those primitives. What about the mutable ones? What were the things that could change? Set list dictionary. Those are the big ones we looked at. And that tuples in this type there, we'll take that out. I'll flash up here this Python tutor tool again. By the way, again, the lecture slides, and sorry, somebody asked for like access to them, the slides from last week, or I guess Monday. They're supposed to be open, so if I accidentally lock them up, let me know. But inside the slides, these links, you can access all of these yourself if you want to follow along. All right, so when we talk about this mutability, when I run this code, over here in memory, this frame, I have my string is associated to that variable. Notice here what I did with string 2. I said string 2 equals string 1. So here's string 2, right? Now, look what I'm about to do on line 5. On line 5, I'm about to set the value of string 1 to a new string. Remember, strings are immutable, so that variable obtains a new value. String 2 does not change. Unless I do what I do on line 6 here, which is say string 2 now assumes the value of string 1. And then the inverse is true as well. String 1 and string 2 have the same value. If I change string 2's value, it changes, but string 1's value does not. That's the whole concept of being immutable. So here are some mutable data structures. So here's my list. Notice what happened here in memory. This variable list points out to a whole other structure out here. When I create another variable list 2, it points at this structure over here. If I'm to make a change to list 1, so here on list 1, I'm going to add the value 4, and then I'm going to change the value of the thing at index 0 to -1, right? List 2 is transitively updated here. If I take list 2 and I say remove something, so I'm going to remove the value 4 from it, and then here I'm going to set the value of index 0 to 1, that changes as well. So both list 1 and list 2, they change in concert because they're mutable. The next thing we have to remember is the concept of identity. So what was that concept of identity in Python?
The memory address of the variable.
Perfect. The memory address, where this thing is stored in memory. What might be a real-world example of identity? So security, that's a good one. So there's a lot of people in this world. There's a lot of people named Dan. Presumably, there's only one person named Dan with my social security number. I was going to say there's a lot of people with named Dan's, but we each have our own fingerprints. But both of those are perfectly good examples. So how is mutability and identity related? And this is really, really key for us to understanding how functions are going to work. Because remember, functions really have 3 things we have to concern ourselves with. Inputs, which are the parameters, arguments, the stuff we do inside, and then the outputs, right? So, over here, I have a bunch of immutable objects. My string, my float, my int, my tuple, right? All of these things here, if I go to print these out, I call that ID function. This is where these things are stored in memory. So they're all unique objects. Now the tuple looks a lot like the list in the set, but as we know, we can't change the tuple. Just because it lives over here as an object doesn't mean I can necessarily change it. But with these data structures as well, the list, the set, the dictionary, right? They all have their own unique locations in memory. So the only point of me showing you this was just to remember we have this ID function. If you ever sort of get lost when you're dealing with a function, right? Put your own print statements in there, leverage that ID. If you're not sure, if you're like, wait a minute, I passed something into my function. Is it the same object? Is it the same instance? Where did it change? You can always use this ID function to figure that out. Okay. So again, I don't want to go into too much detail. I don't want to be just teaching what's in the book, but this is what's from the book. Those arguments that we pass into our function, it's called pass by assignment, which basically means the thing we're putting in, the argument we're putting in, we're referencing it, but we sort of, in some cases, have a copy of it, or we have the exact same object. And we'll take a look at that. I'll try to demystify it. So let's use this Python tutor thing again. So I have a function here, and notice what I'm going to do here. This function is going to take one parameter, and I'm calling it the object param. I don't know if it's a string or int, and I don't care because it's dynamically typed language. And in here, I'm going to print out the ID of that object. So let's take a look at some of these immutable objects, what happens here. So here's my function. It's just sitting there waiting for me to call it. Here's a variable myString. So we can all agree I'm not inside the function yet. This is the ID of my variable myString. Now I'm going to call my function. And look closely. This was the object. This was the memory location, the ID of myString. This is the memory location of object underscore param. So notice it's the same at this point in time. Now, if I go in here and I say, I'm going to print object underscore param, see what that looks like. Just say 1. I'm going to change it here. Object underscore param. I'm going to say it's a number. 5, 6, 7, 8. Let's run this same code. So my function's been declared. I haven't stepped into it yet because I haven't used it. So I created this myString variable. It has this ID, blah, blah, blah. I come into my function. Still has the same value of myString. I changed the value to 5, 6, 7, 8. And notice that the object ID changed. So that action I took changed that parameter. That's important because this is the memory location that stores what was in myString before we went into the function. So now when I leave this function, that ID, anybody want to predict what that ID is going to be? Is it going to be the one that ends in 256 or the one that ends in 104? 56. So get comfortable with that a little bit. Here is something that's mutable. So I'm going to take my list. I'm going to pass my list, and actually I got to back out that code up there because I don't want to do this groovy stuff. Let's just run past this to the list. Now I have that list function. This is its ID. It ends in like 240 or something. I come inside here, it's the same 1. And I come out here and it's the same 1. Okay. So if I want to now change this thing up inside here, now I know this is a list. I could say object param at index 0 equals apples, something like that. I don't know. So I have this list that was 1, 2, 3, 4, 5. I go into my function here. I change that thing to apples. It's the same object. When I come out, that change was reflected here. So I'm going to show you at the kind of the end of this section how to pass in a list so it doesn't change. So we don't sort of have that effect here. Actually, sooner than I thought, that was here. So in this example, I have this function. Again, nothing executes because I'm not in there yet. Here's my list that has 1, 2, 3, 4, right? I'm outside my function. That's its ID. I come inside and I clear it, right? So I've cleared that object. Now, when I come out here, right, it's the same object, but it's an empty list. If I didn't want that list to be emptied, right, so I'm going to create another thing, my list 2. From what we learned about strings, what does that syntax do? Square bracket with 2 colons in it.
All of them,
What's that?
like all the.
Yeah. So what that is, so if you remember from slicing, right? We learned slicing in strings. I'm going to go through lists and slicing very fast because it's the same thing. It's the same syntax. When I do this, it basically takes that whole object. It basically makes a copy of it. So now when I run inside here, look at what happened to object param. It pointed at a new list. So now inside that function, the thing that I cleared was a totally different object, right? And so now I can do stuff in that function without affecting what happened outside. And you can see here, you know, it's a different object inside the function versus outside the function. In some cases, you might want to have your object change. Sometimes you don't. This is how, in the vast majority of times, you want a mutable thing to be mutable. You want it to change. But in that off chance that you don't want it to change, that's where you have to sort of do this copy, where you have to do this slicing. Okay. This is kind of where the Taco Town stuff comes into play. This is the function definition that we've come to know and love. Just like we were learning with our other functions, this is how we name our parameters. And I've seen some people do this. I know for sure if you feed your stuff into ChatGPT and say generate code, hands down it does this all the time, which is weird because you normally don't. Hint, hint, that's how a lot of times AI gets flagged, because this is kind of unusual. But if I have 2 parameters, P1 and P2, this is how I call my function. When I call my function, I can say P1 equals cat, P2 equals dog. Typically, you just want to fit those 2 things in, just cat and just dog. Remember what I always say, we're lazy. Why would I expend my energy to type these extra characters when I could just type cat and dog? But what's the result of this function? Well, I'm just calling my function with 2 parameters, and it prints out, you know, hi cat and dog. These parameters don't have to be in order. This is something kind of unique to Python. Other languages don't have this. Other languages, parameter 1 is parameter 1, parameter 2 is parameter 2. Here, if you wanted to, you could invert it and say P2 equals cat, P1 equals dog. Can anyone predict what the message is going to be in that case? Yeah. It's going to say hi dog and cat. So, you know, positionally, in this one, I put in cat and dog, and it prints out cat and dog, but here it prints out dog and cat, because it's using this name to determine which parameter it is. You can also intermix these things, but there's a rule here. If you're going to use a named parameter somewhere, anything that's not named has to come to the left. It has to come first. Part of the reason is it's simple when you only have 2 parameters, but when you have like 200 parameters, the interpreter doesn't know, hey, is this the first one or the second one or the third one or the fourth one? It doesn't know which parameter to replace. So you can intermix unnamed parameters with named parameters. Again, I don't know why. Well, I do know why, but ChatGPT Gemini, it's going to do this. There is no human that I've ever met who wouldn't do this in their right mind. So the key takeaway here is what we learned about the function declaration, that doesn't change. This matters how, when we call the function, we call it like this. Couple no-goes here. I have parameter 1 and parameter 2. Well, this is in parameter 1 slot without a name. And then I'm saying this is parameter 1. It's going to give you an error. The interpreter is going to say, yo, you're trying to give me 2 things for parameter 1. I don't know what to do. It's not going to make an arbitrary decision. It's like, listen, you made a mistake, human, figure it out. And again, like I mentioned here, you can't put a named parameter before a positional one. That's going to throw you an exception here. Okay. The second topic under arguments and default parameters. This is kind of new. For my parameters, instead of just saying P1, comma P2, I could say P1 equals cat and P2 equals dog. This allows me to make my functions have an optional parameter. So remember input? That's how we started learning input just with open paren, closed paren. And then very quickly, I told everybody, hey, let's start putting in a prompt here. Whatever our prompt was. If we were to look at the definition of the input function, it would look like this. Input, here's a named parameter called prompt with the default value empty string. That's why it doesn't print anything when you don't pass a prompt. So my function with no parameter, who wants to predict what that's going to print out? Say again? Yeah, it's going to print out high what? What's it going to print? High what? Yeah. Hi cat, hi dog. So you as the human don't have to put anything in. You've already told the interpreter, hey, listen, if the human doesn't give me anything, use what you know. Now, if you human pass something in, the interpreter is going to say, okay, right, I know I have 2 parameters. You gave me 1. I'm going to assume this is the first parameter. You didn't give me a second one, but I have an idea of what you want me to use. So that's going to print out hi, rabbit, and dog. Similarly, it's superfluous and unnecessary, but you could say P1 equals rabbit. If I say that, that'll do the same thing. Here, I'm saying specifically P2 equals rabbit. What's that going to print out? Hi what? Yeah, hi cat and rabbit. Why? Because I'm telling it, hey, interpreter, I don't know what the first parameter is. I'm only giving you 1 thing, but I want you to use it for parameter 2. I could similarly do this, but again, this is superfluous here. In this case, it's going to take rabbit as the first parameter and mouse as the second parameter. So with these, you just have to play with this a little bit. This is sort of like the format string stuff I talked about. 99% of the time with format strings, you're going to deal with like formatting floats. Same thing with parameters. We don't do this too much. You probably will in your project when you're creating your functions. But realistically, I know my parameter takes, or my function takes 2 parameters. I don't really need to go through all this work of naming them. It's really only useful when you have, a lot of parameters. Okay. Word soup here. Default mutable parameters. What does that even mean? Well, let's take a step back. This is a parameter, obviously. This is the name of a parameter. This is the default value. So far, I've just shown you a string. And a string is mutable or immutable? Immutable. So what happens if I'm going to pass in a mutable parameter? I want a default mutable parameter. This Python tutor thing comes in handy for this module. Let's take a look at this function. So I have a function here called myListDiddler that takes one parameter, which I called list underscore param. I'm initializing it with square bracket, square bracket. That's a list. Anytime someone calls this, I'm going to take my list parameter and just put a random number in between 0 and 100. Then I guess I'm printing it out. So there's my function. It's been declared. Look at what happened right off the bat, though. MyListDiddler created me a list param out here somewhere in memory, create an empty list. Well, that's kind of what I told it to do. That's an empty list. Now I'm going to call my function. So flow of execution comes up here. I drop in here, and this added random number 49 to my list. Okay, that makes sense. I'm cool with that. I'm going to call this function again. This again is one of those things that I really don't like about Python. Really confusing. I could probably do a little bit more academic research to find out why this is the case, but I think this is really confusing. When I call this again, my intuition is like, oh, okay, it's going to initialize list param to an empty list. But it actually doesn't. It says the first time it was initialized, I'm just going to use that same list. And it appended the value to this list I had in this previous call. And now I do it a third time. It comes in and appends it to that list. I think this is very confusing because the primary reason we have functions is because I want to reuse it. I want to use it over and over and over again, right? We have the length function because it would be a pain in the ass to write a for loop going over every character in a string every time we want to get the length of a string. So we have functions, right? Well, length, I'm calling over and over and over again. Well, what happened if length sort of set an initial state and your program's been running for 23 years? You still wanted to have memory of what happened 23 years ago? So I find that a little bit confusing. I will have to let you all know if I can figure out a reason why I would ever find value in that. I don't find value in that. But being that this is an introductory course, we should have an appreciation of mutable, immutable parameters. We should have an appreciation of those default values, and there's a ramification if it's a mutable versus an immutable object. Okay. So again, if you're following along, you could go into Blackboard assignments, assignment 7, and you'll find here we're going to do 7.3.1. If I fat finger anything in here, you always have the solution here. Just a reminder, when you're doing this, please make sure you hit your own sort of submit button at some point, because you will get a point when it comes time to doing the assignment. Okay, so let's take our memory back to assignment 1, where we did simple interest calculation. We're going to create a function called simple interest that takes 3 variables, principal, rate, years. We're going to calculate the simple interest and print a message. Cool. Let's get rolling. Def, simple interest, and it takes 3 variables. or parameters more precisely. Principal rate years, colon, indent. Interest calculation is principal times rate. I'm going to assume, like last time, someone's going to enter in the value 5 for the percentage, so I have to divide that by 100 times years. Now I want to print out a message. I still see people struggling with this, so pay attention and watch the pro tip. This is not really too hard. When I want to print a formatted string, anytime I want to print a variable, this is what my instinct should be. Right? Print F in 2 double quotes. Please get out of this habit of doing that and then putting a variable and doing stuff. When you're going to do a formatted string, this is what you do 99.999% of the time. Okay, so I'm lazy. Copy that string, put it in here. I know this is a variable. That was principal. And I want 2 decimal places at a rate of rate. I'm going to assume that's a float. And we'll earn interest, same thing. That's a float. And years. I gave myself a head start this time. So I have a print message. I'm going to read a float from input, a rate, a years. All right, let's run that up. Okay, principal, $1,000, 5% rate for 1 year. What happened? Oh no, I didn't call my function. So let's call my function. Simple interest. My argument is in principal. My argument is in rate. My argument is in years. And those will get assigned to these parameters when I go inside there. Let's try that again. 1,000, 5% for 1 year, I make $50. All right. So this had nothing to do with named parameters. It had nothing to do with default values. Just sort of tying together what we learned in assignment 1. Now I leverage the function. Now is where we're going to apply these new skills. Part 2, use name parameters. Call simple interest in various ways using parameter names. All right. Let's do some of these. So name all 3 parameters. So here I can say my principal is in principal. My rate is in rate, and my years are in years. Just make sure, principal, rate, years. Run that up. Do the same thing, 1,000, 5% for 1 year. Uh-oh, keyword principal, I used the wrong version. I used the, sure. Like so many people did the assignment. Yeah, I get caught up in it too. All right, 1,000, 5, 1. Okay, same answer. Gets me 50. Name the second and third parameter only. So instead of putting in principal, I'll use that actual value without the parameter name. 1,000, 5, 1. Cool. I'll use 2 positional. 1,000, 5, 1. Right. Again, let's remember it's a function. I could put in whatever number I want here. Maybe I want to make 8% interest. Maybe my time is 3 years. I don't know. We could do the math on that later, but theoretically, that's what that will make. Okay. Now, if I do this, principal equals in print. What's going to happen when I do that?
Whatever value you put in for information.
Positional argument follows keyword. So remember, if I want to use a name, none of these positionals can come after it, right? So doop doop doop. This 1000.51, that will work because I have the named parameter after my positional ones, right? But again, if I do anywhere to the left, if I say rate equals in rate, they give me an error. So keep those in mind. Okay, let's introduce into this problem default parameters. Modify simple interest to specify a default for some or all of these parameters. Okay. Gonna take all this code here. Let's move this down. So here's my function, simple interest. I'm going to say the default principal is $1,000. And I'm going to say the default rate is 5. And maybe I'm not going to specify a default for years. I don't have to. Now, if I call my function simple interest, right? Principal has a value, rate has a value, years doesn't. I could say years equals in years. That's my parameter. This is my argument. If I run that up, oops, what did I do wrong? Line 15. Why doesn't it like that? Let's just add a year in there. Can't believe I broke that, but. So let's only put in here years. So I'm going to put in for principal 90. I'm going to put in for rate 87. And I'm going to put in for years, time, whatever. I'm going to put in 10. So notice I'm only passing in years here. So here, $1,000 at a rate of 5%. Well, I entered in a rate of 87, but I didn't put it here, so it took the default 5. I had the default 1, but it took the one that I put in here. As I'm doing this, I didn't realize, if you notice this little flub here, I did this. I didn't realize when you put defaults that you have to have a default for everything there. That's interesting. Now I can put this like this, I think. I could do that. That should be valid. And so here, if instead I pass in my principal and I pass in my rate, I don't have to pass in a year in this case. Let's run that up. Principal, say 1,500. Say rate 5, time, some big time. But I didn't pass that big number in here, so I used my default of 4. Okay. All right. Arbitrary arguments list. Back to this. This is our Taco Town connection. Are we done yet? No, we're not. Not even close. So, in addition to these named and positional parameters, we have another thing called arbitrary arguments. Star ARGS. Are we done yet? Nope. There's another one, KWArgs. Zybooks does a pretty good job of explaining all this, how these work. But suffice to say, KWArgs versus args. KW stands for keyword. So basically it means I can pass in a dictionary. Args, you all have seen args, and you've been using it over and over and over and over again. So when I call print, how many parameters are in print? Don't I often do something like this? A, comma, B, comma, some variable, AR1, some variable, AR2?
Yes.
Yeah. So print takes an arbitrary number of variables or of parameters. And so if you look at the signature of that, if you were to write the print function, you would see def print star args. The real magic there is how you use args inside the implementation of your function. Yeah, we'll do this one. So let's create your own print function by print that takes an arbitrary number of parameters. It prints each delimited by a comma, right? So remember our prints today that we know and love, when we do that comma thing, it separates things by a space. So if I was to create my print, if I said star args, the long way of doing this, we'll just do it for giggles, for item in args, print my item. In this case, I want to delimit it, what did I say, by a comma. Now, if I were to call my print with apples, pears, whatever I wanted, it printed out apples, comma, pears, comma, right? Not quite what I wanted. Hopefully, people who have been absorbing the material realized you could do this instead, comma, dot join args. Just print that out. Much simpler code than trying to do that loop. And it got rid of that annoying problem where I had that rogue comma at the end. So let's enhance this. So instead of just taking a list like that, I can pass in any delimiter. Here, I would make my first parameter delimiter. And then all I have to do in my code is say, use my delimiter as the thing I'm joining on. So now, my first parameter is a $, and I have apples and pears, and I can have apples and pears and pickles and whatever. Let me just add a F on this guy. Apples and pears and pickles with a $. And if I didn't want a $, if I wanted to have 4 dashes, apples and pears and pickles. So what I did here, I think, is pretty neat. I created my own print function. All right, I'm going to leave KWR. Hopefully you got some context out of this, how it just builds, keep going on forever. Coming up, as I mentioned, 3 o'clock, I'm not going to be in office hours. 4 o'clock, we can start the code jam, anybody who wants to do that. Reminder, assignment 6 is due this evening. Friday, we will do the exam prep. Just for your background information, this is what we did. We created exam 2. We made a copy of exam 2. We changed the variables. We changed some of the plus and minus to greater than, equal to, less than. If you do the exam 2 prep, you know exactly what will be on the exam. There will be no surprises. We will return to functions next Wednesday. Don't worry, none of the homework, none of the labs, all that stuff we'll be doing until later. But tomorrow in lab, we will be functions. Right, y'all? Ciao.
Looks like a-